Please welcome to the stage Dr. Whitney Mason.
Good afternoon. Today, Dr. Jamal Molen had prepared for you a really fascinating briefing about enhancing edge processing imagers with in-pixel processors. Due to an unexpected illness, unfortunately, what you get today is me. So you should direct any praise, if you enjoy this presentation, any praise you should direct to Jamal. Any disgruntlement, well, keep it to yourself. So today, modern society, we have lots and lots of imagers in the world, right? They're all over the place. They're in space. They are in medical devices and security cameras, in our cars, in our homes, and in our pockets. And in fact, by 2025, expected data output is expected to be 465 exabytes every single day. And this is an enormous amount of data that we're going to have to process and store and do something with, right, to create information. But that requires an enormous amount of power. But we need to be able to do things with this to make this imagery useful. And so there's a couple examples up here over on the left. You just saw the video. This is from the BDD 100K data set. It's a well-labeled data set that people use to develop algorithms for autonomous driving. Over on the right is an example of UAV over some contested zone, which is trying to extract useful information. But it's projected that processing that data will require over 12 TOPS of processing. And this is exactly the challenge that this thinking is meant to address. Moving data off the camera is expensive, but even just moving data off the chip is expensive. So a large format, high frame rate, high dynamic range camera is expected to output 100 gigabits per second. And so what we do now is we move the data from the sensor to memory and then to some other processing engine, and that takes lots of time and that takes lots of energy. There's been lots of work. DARPA's invested in some of it, looking at how do you make the processing at the back end faster, right? How do you break the memory wall? High performance accelerators, better compute capability. But I argue, Jamal argues, that you need to think about moving this processing elsewhere. So trying to avoid that energy loss, that delay loss, by moving the data from someplace to someplace else. So let's step back just a minute and think about the way we do things, right? The human eye has the equivalent of about 130 million pixels, and yet our brains aren't smoking, right? When we manage to walk down the street and find friends that we know. We can do this. Why can't we inject this into imagers? Well, you might know that the way the eye brain works is it's a combination, and actually we do a lot of that visual saliency, the extraction of relevant information, right, at the eye, and it coordinates with our brain, and it does this in two ways. First of all is task-driven, right, where the brain says, count how many people are in the audience. And then there's the bottom-up saliency discovery, where we say, hey, there's a guy in a pink shirt right there, right? So something catches our eye and it creates information in our sensor, in our eye brain. Why can't we use that same sort of neuromorphic approach, that bio-inspired capability, to ingest into our cameras? There is, in fact, a way of doing that, and that's by putting the processing right at the pixel level. So instead of transporting that data from the chip off to some display or computer, let's put processing right under the data and extract only relevant information, just the way our eye does before it shifts it back to our brain. And you can use time, you can use spatial extent, you can use texture, you can use all sorts of different formulations, color, in order to extract that information and do it very quickly and avoid that energy time delay. There's lots of programs. The DARPA Fence program and the in-pixel processing program are both working on exactly that. And you can see some of the chips that Jamal in particular has worked on to do that data saliency extraction as early as possible. I believe that this in-pixel processing capability should move forward into all of our imagers in order to create data products, information out of our sensors instead of just lots of data. Thank you very much.